Okay, so I want to better have you understand what this notation means and how to better think and visualize it when you want to use it. I'm just going to write out this n a little bit larger. Okay, so what does it mean when you say n choose k, which oftentimes looks like this? What it means is, let's say you have 5 markers, right? And you're looking to pick a marker out of these 5. We're going to say 5, the markers you have, choose 1. You would pick 1 marker out of this bunch. So you would say, that would be like saying 5, choose 1. If you wanted to choose, for example, out of these beautiful markers, we have a black, a red, a green, a purple, and a blue. Let's say you want to choose 2 out of this 5. Well, you would then say 5, choose 2. You would take 2 of the markers out and you would say, these are my chosen 2 markers, right? Not quite. Something I didn't mention yet. Very careful. When the human brain thinks about choosing something, oftentimes if I say choose 5 markers out of here, most of you would have probably chosen the first color and then looked around and chosen the second color. That is not how this notation works. This notation isn't about choosing something in an order. It's about just choosing a number. So if I say 5, choose 2, you're choosing things at the same time. That's how the way I like to think about it. You're choosing these 2 same time. You're not choosing one and then you're not picking this and then picking this. You're grabbing them both at the same time. Another way of thinking about it, because the order in this notation doesn't matter. It doesn't matter the order in which you choose your 1 or the order in which you choose your 2. It's simply how many ways can you choose 1 marker? How many ways can you choose 2 different markers, right? That is important. This notation does not mean that when you have 5 markers to choose from and you're choosing 2, that first you choose 1, you put it back, and then you choose another. Because you're grabbing them at the same time, when you're choosing 2 out of your 5, they have to be 2 different, 2 distinct. It cannot be that you're going to choose the purple marker twice. Because we're choosing markers at the same time and we're choosing 2 of them, they will have to be distinct. You can't split this marker into 2. So I hope that better explains that this notation means order does not matter. And then second of all, what it means is that everything you choose is going to be distinct. K is distinct. So once again, to reiterate what these 2 points mean, this means that if you, let's say, have the marker, well, let's say you have numbers. We'll go with numbers for this case. If you have 1, 2, 3, 4, 5, right? And you want to choose 3 out of these 5. You want to choose 3 elements in this set out of the 5. Well, then in that case, what you're going to say is, okay, choosing 3, 2, and 1 is the same as choosing 1, 2, 3, which is the same as choosing 2, 1, 3. Doesn't matter the order in which we select these 3 numbers. It just matters that we selected those 3 numbers. That's what order doesn't matter means. This means that if you, for example, instead chose 2, 3, 1, it's going to be the same as saying choosing 1, 2, 3. And that kind of makes sense with sets as well, right? It's the same choosing different orders. We care about the elements in the set, not the order in which the elements are in the set. Distinct. What does distinct mean? Well, if we go back to our example with our 5 numbers, it means if I want to choose 3 numbers, I cannot choose 1 number 3 times. You cannot do that. What you have to do is choose 3 at the same time, which means you have to go, okay, 1, 2, 3. I'm choosing all 3 of these at the same time. So that's what those 2 points mean. When we're using the n choose k notation, the order of our k doesn't matter, and you cannot choose an element more than once. So how would that look like with our other notation here? Well, when we had the 5 markers, that would be 5, choose 1, when we were choosing 1 marker. When we were choosing 2 markers, it would be 5, choose 2. And when we wanted to choose 3 numbers, it would be 5, choose 3. That's how you would write those. A better example to illustrate how this notation, how you would set it up, would be, for example, using a classroom analogy. Let's imagine you are going to be a teacher, right? You're a teacher at the front of a classroom. Here's your little whiteboard, right? And you have a classroom of, let's say, 9 students. Let me draw all 9 of these desks out. Okay, you're a teacher and you have 9 students. And let's say you ask the classroom a question and you have every student in the classroom raise their hand, right? Everyone, this is going to be everyone raising their hand. All 9 students raise their hand to answer the question. Now, a teacher, when wanting to choose a student to answer the question she asks, she would usually choose 1 student. You would never ask, for example, what is 3 times 2, and have 2 people answer at the same time. You would choose 1 person to answer that question. So in this case, our choose notation would look like 9 choose 1. The 9, because all 9 students are going to be who you can choose from, and 1, because you're only going to choose 1 student. If, for example, let's say these 3 students here didn't raise their hand, and you're a teacher that only calls on students that raise their hand, because these 3 did not raise their hand, and you're still only going to choose 1 to answer, the only students you can call to answer your question are going to be the ones with their hands up. So what does this look like? Well, this is going to look like 6 choose 1. Why is it 6 choose 1? Because out of the students that you can choose from, it's going to be 1, 2, 3, 4, 5, 6. You are not going to choose these students because they didn't raise their hand. And you are still choosing only 1. That is where we got the 1. You're only choosing 1 student. And 6 because only 6 of them raised their hand instead of 9 of them having raised their hand. Okay, what if, for example, instead you wanted to call up to the front of the class some volunteers, right? Let's say you said, hey, I need 2 volunteers to come up to the front of the class. And let's say this is not up for discussion. It doesn't matter who raises their hand. You're just going to pick 2 students out of your class. Well, that's going to be written as 9 choose 2. Let's say you choose 2 of them to come up to the front of your class, right? Why are we choosing 9? Because you have 9 students to choose from to come up to the front of the class, and you're only going to choose 2 of them. You're choosing, let's say, this student and this student. That is how you would write down this. Now let me remind you, this is a counting piece of notation. This over here, when we were raising hands, is how many ways can you choose a student out of your class to answer a question. This down here is simply going to be out of the 6 students that raised their hand, how many of them can you choose to answer your question. Here, because you have 9 students you're going to choose from to be 2 of your volunteers, this is every single combination of students, of 2 students, you can choose to come to the front of the class. So this is 1 combination. This is the 2nd combination. This would be a 3rd combination, right? This is all of the combinations of students you can choose for this specific scenario. Okay, what if instead of choosing 1 of your 9 students, instead of choosing 2 of your 9 students to come to the front of the class, you instead chose all of the boys to come to the front of the class, or not all of the boys. You need a boy to come to the front of the class. Well, let's say the 4 seats back here are going to be girls in the class. So the cross now, actually, let me just draw this using maybe a triangle. I'll say the girls are going to be triangles, right? And the boys are going to be nothing. The boys are going to be empty desks. So you're going to choose the boys out of your class to come up, and you're only going to choose maybe 3 boys. So what is that going to look like? Or maybe let's not choose 3. Let's stick with 2. So now you want to choose 2 boys to come to the front of the class, and your class has 5 boys. 1, 2, 3, 4, 5. So the way that's going to look like is the following. It's going to be 5 choose 2, right? You are still choosing 2 students. That's where we got the 2 from. But the students you're able to choose is only going to be 5. That's where we got the top number from. So what do we notice from these examples? Well, what we notice is the top number up here, and here I'll circle it in blue, or I'll underline this in blue, the top changes when your options change. So we went from 9 desks to 6 because it went from 9 hands up that you can choose from to 6 hands up. We went from 9 students you can choose to go to the front of the class to 5 students you can choose to go to the front of the class. That is why the top number changes. The top number changes when your overall choices change. Okay? When does the bottom number change? The bottom number, the K, changes when you're looking to choose a different number of students. For example, here, out of the 9, we only wanted to choose 1 student. Whereas here, out of the 9, you wanted to choose 2 students. Now remember, and this makes sense too, whether you choose, for example, in this case here, this boy and this boy, it's not going to matter whether you chose him first, or him first and him first. It's still choosing the same 2 boys. Again, reinforcing that idea that you are in fact choosing them at the same time, or another way of thinking of it, the order does not matter in which you choose, it just matters who you choose. The other thing to notice is, because we're saying 9 choose 2, you need 9 of your students in the class, or let's stick with 5. You're choosing 5 boys out of your class. Sorry, you're choosing 2 boys out of the 5 in your class. It doesn't make sense for you to choose the same boy twice. That's not going to be having 2 boys come to the front of the class. It's just going to be 1 boy. You need 2. So that's what we mean by distinct. When I said the numbers here are distinct, you cannot choose the same thing twice. This is an example where that makes intuitive sense. If you need to choose 2 boys out of the 5, you're not going to choose the same boy twice. That's still going to be 1 boy coming to the front, but you need 2 of them. Okay, fantastic. So what did we learn from this overall at the end? Well, what we've gathered is that with our n choose k notation, we have found out that what this notation means is order does not matter. We also found out choices are distinct. You're not putting the markers back and choosing a second. You're not choosing 2 students and then choosing the same student twice. That doesn't make sense. And then what else did we learn? We learned n changes when your options, I'll call them, change. And then k changes when how many you're looking to choose changes, right? If I went to a store and there are, let's say, 5 lawnmowers, I can only really choose 5. I can choose none of them, 1 of them, 2 of them, 3 of them, 4 of them, or all of them. That is what this means. But if I am looking to only buy or to choose, let's say, 2 of them, that would be our case. So if I'm looking to go buy lawnmowers, I have 5 to choose from, but I'm looking to only get 2 of them. So that is how this is going to look. So I hope this explains a lot better what this notation really means when you're going to be using it for our counting problems.